Okay, let's get the show on the road. Hello, everyone. Hope you're well. Welcome to another edition of Math 1203. Final day. In fact, the final day was yesterday, but figured you guys might have time. Because feel like it's been a while since we checked in. Some of you guys still can't see your faces, and no one's gonna. Even on the last day, you won't actually turn your cameras on. It's so sad. Okay, so what we will be doing here is just no new material to cover, nothing really to go over, but I just wanted to touch base, make sure everybody kind of knows what's going to happen, kind of just hopefully calm everyone down, answer some concerns, that sort of thing. I think that would be good for us to just do a quick check-in, make sure that we all have a plan for the coming week. The most important week of your lives. I'm kidding, it's not, but I know this time is very stressful for everybody, so I just wanted to, just chat for a while about how things are going to go. So you did your test 2 last week. It's actually not done being graded. I haven't finished grading it yet, but the solutions are posted on Piazza. You guys should see an email about that. Another thing you have to remember is that all homework is due tonight, I believe. Which might sound like it's last minute, but I actually had it due for Sunday before, and then I extended it tonight. So if you didn't know about the homework at this point, you probably wouldn't have finished anyway. Okay, so just to remind you, our final is a week from today. So it is Wednesday, December 16th. It begins at 9:30 a.m., so you can get an hour extra sleep. Hopefully you actually take advantage of that and you don't have any last minute studying going on. Just kind of, what you can do is kill yourself this week, and then next week you do want to make sure you're very rested. So as someone who's been not well rested this past week, I can tell you don't want to go into finals week being frazzled. So kill yourself this week, and so next week you can incorporate rest while you're studying, while taking finals. So that's that. As for the final, you might be interested in what it's going to look like. So I guess I'll talk a little bit about that, and you can ask me some more questions if you want. Whatever concerns you have, just let them be known now, and I will answer them. But the format of the final is it is cumulative, so it covers everything that we've done. The problem types are going to be very similar to the problem types for test 1 and test 2. So whatever test 1 and test 2 felt like, just think of that being combined, and that's almost what the final is going to be like. The final is going to be 2 hours and 15 minutes. Now, in total, how many things you'll have to do? It's going to be about 20 to 25 individual items, individual problems that you have to do, and you'll have to show your work for most of it. And I mean, it sounds like a lot since I've been labeling questions with different parts, but on our test, you've actually been doing roughly that number of things. For sure on the first test. On the second test, you probably did a little bit less than 20 individual things. However, some of those things on the second test were much longer than long form problems. So it probably didn't look like that by the numbering of the questions. So your final, the number of things you'd have to do is roughly the same number of things as you would have to do in just a regular test, which you'd have about an hour and a half for. But now I'm going to give you 2 hours and 15 minutes. It'll be on Gradescope, just as usual. So the morning of the final, you just log into Gradescope, you take the final. It'll have the time there. Those of you who are accommodated, who have accommodations for extra time, it'll be built in just as usual. Everything is just business as usual. I don't want you to think of this as some, oh my God, this is different. It's business as usual. Think of it that way. You'll do fine. If you've been doing fine, I don't expect you to not do fine anymore. And I actually think that it will actually give a lot of you a much needed chance to improve if you have to improve. Because of course, the more work you show, the more partial credit I can give. So that's overall what the final is going to look like. I've already started thinking about the problems I'll put on it, but I haven't actually written it up and packaged it yet because I have finals for my other class before I have finals for this class, so I'm focused on those finals first. So yeah, overall, that's kind of the game. At this point, I just want to reach out to you guys to see if you have any questions or concerns or comments on test 2 or the final.
Are you going to be including bonus questions on the final or no?
So no. So bonus questions are usually to reward those who read ahead. And so because we've covered everything in the syllabus, there's nothing to read ahead on. So there will be no bonus on the final.
Okay, thank you.
But the final itself would kind of be like a bonus in that sense that, you know, I said this earlier in the semester, but that's been a long time now. But the final is actually your chance to prove that you've learned from your mistakes in the past. So let's say, you know, you've had a couple bad quizzes, you had a bad test 1 and you barely really even improved more on test 2. If you can do really well on the final and show that, you know what, I learned beyond my test 1 score, beyond my test 2 score, you know, I'm going to count those less in your against you. You know what I mean? So it's like I'm not going to judge you for who you were 2 months ago. I'm going to judge the person in front of me right now. So in that sense, the final itself is a bonus in the sense that if you do well on it, your past transgressions, I have to hold it against you somewhat because those are the rules, but I'm not gonna, you know, you'll have a lot of brownie points. I'll be more inclined to bump you up a half a grade or so if you show improvement, which there's already kind of a bump or a curve on the class. I'll actually talk about that in a little bit as well. But officially, no, there are no bonus points on the final. It's do everything and it covers the entire syllabus. Other questions? L'hôpital's rule. Okay, so what you need to know for L'Hopital's rule. So L'Hopital's rule only comes into play when you're trying to find limits, pretty much. So what you need to remember for L'Hopital's rule. So the first item, what you need to know about is indeterminate forms. You should remember that these are limit forms, right? So it's not like these are actual numbers. These are, when you're taking a limit, this is the behavior that you're exhibiting. There are about 6 of them. So it's like 0 to the 0, infinity over infinity, 0 over 0, 1 to the infinity, infinity minus infinity, infinity to the 0. I always feel like I forget one of these. It should be obvious when you see them, but I think there are about 6 that we've covered. And you should know that L'Hopital's rule only helps with these. And the idea is, if you try to simplify or write these. Okay, so that's the first thing. You should know when and where those rules might be a strategy that you'd want to do. And it's pretty much whenever any one of these 6 situations as far as I'm concerned. So it's that you know Lopez rule only on the cases on the right. If you have other cases, you either have to do something else, like maneuver somehow. The other strategy limits it to a Lopez rule form. I'll talk about it in a little bit. With logs, we have the ability to. Second thing you need to know is look. So it has a bunch of stuff on continuity and blah blah blah, yada yada. But eventually, what you need to know, as far as a student is concerned, is that we have a limit that looks like a division of functions. It approaches 0/0 or infinity, or minus. If we have a limit L equals blah, right? So this is the important part. Limit behaves like, so both the top and bottom are going to 0, or both the top and bottom are going to be plus. Okay, so have your numerator and denominator getting very small going to 0, or you have your numerator and denominator getting very big going to infinity. Then if L exists, it turns out that L would give you the same answer as if you just take the derivative of the top and the derivative of the bottom. And you may repeat this as necessary. Okay, so those are the 2 main conceptual facts I would say you need to know about L'Hopital's rule. So you need to know when you're in a situation where you might have to use it, and then know actually how to apply it when you're in such a situation. So I can give you, of course, some quick simple examples off the top of my head. So for example, if I ask you about the limit as x approaches 0 from the right of x to the x, right? So one thing you're going to notice is that if x is going to 0, then the denominator is going to 0, and also the numerator is going to 0. So that's an indeterminate form. Indeterminate form basically just means you can't tell what the answer is at face value. Because on one hand, you have a rule that says when you raise something to a power 0, you should get 1 as the answer. But then on the other hand, you have a rule that if 0 is in the base, then 0 should be the answer. So you kind of have these conflicting ideas. Is it 1 or is it 0? Or is it something else entirely? Because now arithmetic doesn't even make sense, right? So you can't really say what it is at face value. So you can't like do the plug-in and just plug it in and calculate it, right? So it's very weird in that sense. So that's called an indeterminate form. However, so that's an indeterminate form that we have here. But of course, you'll notice that it's not an indeterminate form that L'Hopital's rule can help with. So now you have to rewrite it. And so if you want to rewrite an exponential, one of the good ways to do that is to use the exponential, the e to the e, right? So we know how to do that. We know that we can write this thing as e to the ln of that thing. Why would we do that? Because the 0 in the power is an issue, and the ln allows us to bring that power down. And so now what we'd realize is that we want the limit as x, this e to the, well, I was going to recopy that. So ultimately now, if we know what this power is going to approach, we can actually tell you it's going to be e to that power. But if you look in the power now, you'll realize that it's 0 times infinity. And yes, I knew it. I always forget one. But like I said, it's obvious when it pops up. Okay. Because the idea behind an indeterminate form is like your arithmetic rules conflict with each other. Like 0 times anything should be 0, but infinity times anything should be infinity. So 0 times infinity is also an issue. So here it's still an issue. So it's an indeterminate form, but it's still not a L'Hopital's rule indeterminate form, still indeterminate. So what you want to do now is convert it. And here is where you can use an arithmetic trick. So I can write the x as something like 1 over x. So 1 over x is the same as x. And now if I look at this, if I look in the top, as x approaches 0 of ln x, I get minus infinity, 0 from the right. And as x approaches 0 from the right of 1 over x, I also get infinity. So now it's indeterminate. But our man's L'Hopital's can handle it. So what L'Hopital's rule says, once you realize you're in that situation, you're going to take the derivative of the top, the derivative of ln x is 1 over x, divided by the derivative of the bottom. The derivative of 1 over x is minus 1 over x squared. So this whole thing here actually now simplifies to e to the minus x. And now there's nothing wrong with plugging in x equals 0. So the limit is actually 1. So the power had more influence than the base did in this case. So that's the L'Hopital's rule. It's the simplest of the hardest examples that I could give. So yeah. So here's one where you have to maneuver it a little bit. You have to maneuver it a couple times. And you can eventually get to a point where you need L'Hopital's rule. But of course, the first thing is to not think that, oh, I could just plug it in and someone assuming just right off the bat that the answer is 0 or the answer is 1, because really you cannot make that conclusion. There are times when it looks like this, where the answer is neither 0 nor 1. It's something else entirely. And we had examples like that in your homework and stuff like that as well. But when you're looking at a limit and you notice that, hey, if I just do the whole plug-in idea, then I get one of these guys. But one of these guys, it's indeterminate. You can't say at face value what they are. So you have to do some maneuvering, or if you're in one of these two cases, L'Hopital's rule can help. So yeah, so then you can look at maybe an even simpler example, just to hit the point home. So another example, pretty much straightforward. If I ask you limit as x approaches infinity of something like ln x over x, or whatever, x cubed, something like that. Notice here, as x goes to infinity, ln x goes to infinity, and as x goes to infinity, x cubed goes to infinity. So that's indeterminate. However, it's a nice indeterminate. It's infinity over infinity, so I can apply L'Hopital's rule. And when you're applying L'Hopital's rule, you can write this little thing over the equal sign so that I know that that's what you're doing. So what I can do is I can take the derivative at the top, derivative of the bottom, and this is just 1 over 3x cubed, which now it's clear that that's 0. And again, we could also figure this out. So this is technically indeterminate, but I did give you guys a strategy where something like this you should actually know off the top of your head. Could also figure this out by the function behavior strategy. We know that polynomials grow much faster than logs. So we know that log to the base a of n is much smaller than something like n to the a, which is much smaller than a to the n, which is much smaller than n factorial, which is much smaller than n to the n. So guys on the right are much bigger when going on when n goes to infinity, as n approaches infinity. Guys on the right are much bigger than guys on the left. So here you could say limit as x approaches infinity of ln of x over x cubed. You can immediately just tell me that it's 0, and then to show your work, you would say something like bottom heavy. So that's another option, but L'Hopital's rule is also an option. L'Hopital's rule is probably the more etiquette, if you want to have, it's the more proper way to do it. This is somewhat an unofficial kind of way to think of, like, bottom heavy showing your work, but I allow it in my class. Because I do want you guys to have an intuitive feel of how different functions relate to each other. So if you can apply that in a problem, I'd be interested in seeing it either way. So yeah, so that's L'Hopital's rule in a nutshell. Essentially, I told you everything you would need to know to solve a problem that would require L'Hopital's rule. If I ask you several limits on the final, which I will, I'll ask you several limits on the final, but at most one of them will need L'Hopital's rule. You should be able to do. In the past, I've asked maybe 3 to 4 limit problems. So there'll be one problem where it just has 4 parts where you have to find limits. And only like one of them would be something where you might have to use L'Hopital's rule, or L'Hopital's rule would be an option. The other ones, it'll be testing you on some of the other limit strategies. But yeah, does that answer your question? Hopefully. So that was like a good summary, I would say. So if I were to really want to know what is the essential things I need to know about L'Hopital's rule, that would be what I would say. But of course, once you know those essential things, you have to do a few examples to get used to the maneuvering. Some problems can be very easy when applying it, but some problems can also be somewhat tricky to kind of figure out how to maneuver it. But this comes with just the experience of doing a lot of problems. But you need to start by knowing how to approach the problems in the first place. So I would recommend just looking over the general limit strategies. I gave you guys about 5 or 6 of them. So just know about some general approaches and strategies to limits, and just know that when your limit behaves like one of these, it's indeterminate. So your plug-in idea and your intuition is not going to work. You have to maneuver things, or if you can move things to one of these two cases, that's where L'Hopital's rule would come into play. Yeah. Other questions?
I have another question, but it's about test 2.
Yeah.
On the optimization problem, so I saw that I believe you replaced the X in the problem.
Hold on. And I think I have it here. Are these it? Is this test? Yes, this is test 2, right?
Yeah.
This one?
Yes. So I replaced the other variable. But then I checked, like, once I saw, like, the PDF that you sent us, and
meaning you did X here and Y here?
yeah. And
it's not going to matter.
Okay. I just wanted to check.
Yeah, you would literally get them solved for in the opposite way. So you would have your X value should be equal to this, and then your Y value would be equal to this.
Well, my answers weren't that simplified. They were like kind of bigger square roots, but then like once I saw yours,
Like
I
this
put
one?
them. No, it was like, hold on. It's like radical 263 or something, but then I like compared your answers with mine and they were the same exact thing, just in like a way bigger, not simplified form. Let me
So
just
you'd have like
open it.
radical 200 and something over something else?
Yes.
I think that should be okay. I mean, I didn't require that you simplify things. The important thing is that the more important to me than simplifying is that you actually answer the question that was asked. So if you made sure that you told me at some point, these are the dimensions, the length is this, the width is that.
Yeah, I got to dimensions radical 243 meters by 162 over radical 243. And those are it's the same exact values as those two.
Oh, so maybe the radical 200 is the same as this? 81 times 3. I don't know. If the numbers when you plug it into a calculator work out to be the same thing,
Yeah, they did.
I wouldn't care in this situation.
Okay, thank you.
I more care about, do you understand what I was asking and do you know how to communicate what was asked? So a lot of times students might stop here and say that's the answer, or students might find the X and Y and think that that's the answer. But it's very important that you actually get to a point where you tell me, okay, the question asked me need to make say dimensions. So that's 6 optimal problem is requests. Going through your problems, I did it by steps, so you can actually see something I was doing it. And it will be appreciated if when you're to work on that as well, also step like this, grading a little turn or I do the proper point as opposed to look, where did he do that? I know he goes straight, don't know where he did it. And then I'd have to do that. One says is everyone else fine? Hello?
Yeah, you've been cutting out a little bit, but now you're fine.
Oh, okay. So I don't know. It might be me. Is it okay now?
Yeah, we can hear you.
Okay. I don't know what's causing that or even what I can do about it. But yeah. So that should be a non. If it doesn't directly in the problem to simplify, then I won't care too much. So like there are times when I'll specifically ask you to simplify, but if not, then if your answer is same in magnitude, it'll be fine. It's kind of choppy. Maybe I'll log out and come back in. Try that. Hello, can you hear me now?
Yeah. Yes.
Yes.
And we're better now, yeah? Okay, and we're still recording, it looks like. Yeah, I just changed my headsets. I wasn't sure if my headset is running out of battery or what, but okay, we're back. All right, yeah, so in general, if I don't specifically ask you to simplify, it's not a big deal. I much more would look for, do I get the impression that this person knows what they're doing? Are their thoughts coherent, and did they answer what I asked them? And even in cases where maybe you gave the answer in an unsimplified form, I wouldn't take off more than a point for that. So yeah, hopefully that answers your question. If you didn't include the diagram, there are some that I specifically requested the diagram. So it depends on the problem. So for example, here, I said your answer should include a properly labeled diagram.
I know, but I didn't realize till after, but I did all the work properly. So
your answer should include a diagram. Yeah. So yeah, you're going to lose a couple points for not doing the diagram. Yeah.
will I still they'll get credit for like the other parts, like doing?
Yes.
Okay.
Yeah. So you'll see it. You'll see right here in the even in the solutions. That's what these numbers are. So you can see how I'm grading everything.
Okay, so like
Right.
let's say
This is why especially it's very good if you rewrite your answers and you set things out in sections, so I can actually see very clearly that I'm giving you all the points you deserve. So here, this one was worth 15 points, and I gave you 3 points for the diagram, 2 points for coming up with the equations, 3 points to plug one equation into the other. So you should know that you need to plug the constraint into the objective. 2 points to know that, oh, now I need to differentiate this new thing and find the critical points. Another 3 points to actually find the coordinate. So here is where you're probably worried that, oh, if I didn't simplify my answer, I won't get all the 3 points. But in this case, I'd give you all 3 points as long as you get the right values, because I didn't force you to, I didn't say you had to simplify. Then 1 point to find the other value, and then 1 point to actually state the answer that was requested.
So like in this problem,
when it comes to partial credit, this is kind of how it breaks down. Like, I know the things that you'd have to go through in order to solve this problem, and I'll give a value to each of those things. And so Yeah, so you should keep that in mind. So don't just write stuff all over the place and just Jhevon will figure it out. Like if I can't see what you're doing in each section, I won't know how to distribute points and you might lose partial credit for that. So make sure you're at least coherent in how you're setting things out.
So like in this problem, it says for the next to the diagram 3 points. So like if it's assuming everything else is fine,
You
like I'll
get
just
12.
lose okay. Thank
Yeah.
you.
Yeah, if everything else is there, you would get 12. So that's yeah. But yeah, so this you guys will see, I believe in the PDF document that I posted, these guys are there. So you guys are aware of how I'm grading it. What I'm looking for, how much points do I value for that thing, etc. I also make comments on other ways that you could write down the answer. So for this one, I did say simplify your answer. Some people might consider simplifying means that they get rid of the E's and LNs because those can simplify, which in class, I never really did that. However, if you did do that, I do recognize that your answer might look like this and you'll get credit for that as well. So yeah, I mentioned, I either put the points or I'll put some notes whether something is acceptable versus not acceptable. Yeah, so that's all there. These you never had to show any work for this, but I wrote comments down so you guys know what I was thinking when I actually wrote the answer here. So yeah, I explained the answer for everything, even when I didn't require you to show work, I showed the work. Yeah. So that goes into a little bit how test 2 was graded, and the final is going to be pretty much graded the same way. So if I ask you to show work, I'm going to have I'm going to do the problem, see, okay, they had to do this to do the problem. Okay, this is worth this many points. This is worth this many points. Yeah. Other questions? I have a question for you guys. How has it been working in your groups? Do you guys check in with each other often? Do you help each other out? You've been doing homework together, studying together? How's it been going with the groups? Put these guys to charge.
Personally, I haven't really talked to my group that much, but I know it's been helpful for a couple of my friends in this class.
Okay. Well, hopefully you're doing okay. They're a good resource. You know, your peers, they're a good resource. So you should take advantage of that, especially going into finals week. You never know if other people in your groups are probably in some of the other same classes you're in, and you guys can trade notes and insights from other classes as well as this one. So you never really know. So I would recommend that you actually touch base with your group members regularly. No man is an island. It's one of the main things that I've regretted, and this is just me being old man Jhevon right now. One of the main things in my life that I've regretted is not networking enough. Like I wish I was better at that, and I wish I did it more, and I wish I talked to more people because it can actually make a really big difference. And you know, it's something I've been working on lately, meaning in like the past couple years or so, and it's so much easier when instead of me doing problems by myself and trying to figure life out by myself, to have other people who say, oh, I've been there, this is what I did, or hey, maybe you should try this. They'll give me ideas that I never thought about. And you know, you end up better for it at the end of the day. And like I mentioned in study hall, even if you don't take someone's advice, because you just don't feel like it would work. Sometimes just hearing their point of view makes you think of something else that you didn't think of before. And so that could be helpful either way. So yeah, networking. One of my regrets. I wish young Jhevon networked a lot more and got involved in more study groups and that sort of thing. I mean, I was busy. I was working while I was going through school and all of that, but I would have, had I known what I know now, I would have forced myself to actually network more. I would have like made it a priority. This is something I'm doing no matter how busy I am. That's how important it is. So yeah. So there were some other questions that a couple of students asked in my other class, so I figured I would also go over that as well. Just how grades work. So I've gone over this a couple times in class, but I guess it bears repeating because I keep getting emails about it, and I'll probably actually send out another email so you can have this in writing, just about how your grades work. At the end of the day, some students are concerned that, you know, going back to the bonus problems question from earlier, if they don't do the bonus problems, does it hurt their grade and so on and so forth. And I just want to say again for the record, bonus points cannot hurt you. They can only help you. They are extra credit, which means a bonus point, the bonus points are your chance to get over 100%. Like if you never do them, you can still get 100%. You can still get A+. They are not going to hurt you. You can not do any of the bonus points I give, and if you do everything else correctly, you'll be fine. So bonus points will not hurt your grade. I understand why some people are concerned also because, well, actually I don't understand, because some people are concerned about this because they see their grade in Gradescope and they realize that the percentage is low. And so that's because the bonus points are counted in the total. However, you should not be looking at Gradescope for your grades. Jupyter grades is where your report card is. When I transfer your grades to Jupyter grades, I change the final total. So the bonus points are included on Gradescope because I want to make sure that I give you the bonus points and you don't miss them. Like if I didn't put them in the total on Gradescope, what would happen is I'd have to manually go through everyone and check that they did the bonus and then tally it up myself and then remember to add that to the things. Like I didn't want to introduce human error into that. So I just made sure Gradescope counts the bonuses. When I transfer the grades to your actual report card, I change the total. So your grades, your average grade in Gradescope will be lower than your actual grade, but it's not because the bonus points hurt you. Like when I transfer the grades, I change the total. So bonus points can't hurt you. In fact, nothing I do hurts you. To go again into what I was talking about earlier about the final being, I'm looking for every opportunity to give you guys brownie points, and I'm looking for every opportunity to give you guys the best foot forward. You'll also notice that there's a discrepancy in your Jupyter grades between the GPA chart that I gave you and in the syllabus, which is the official GPA chart, and your letter grade in Jupyter. And the discrepancy is actually in the positive direction, meaning your letter grade is going to be equal to or higher than your numerical grade. So that's again to just make sure that I'm being fair, like just to protect you guys against, oh, you know what, I think Jhevon graded too harsh. Yeah, I've already accounted for that. I gave you all this extra curves built into the class that accounts for that. So while officially, for example, officially to get an A minus, it starts at a 90%, but you'll notice in your Jupyter grades, if you have an 85, you get an A minus. Like I just automatically just think, hey, this person could conceivably be, not very likely, but this person could conceivably be 5 points higher than what shouldn't have. So you guys already have a bump built into the class. And the bonus points can only help you. It gives you over 100% bonus points from rolls over within categories. So if you get over 100% on one quiz and you get under 100% on another quiz, I'll take the extra here and add it to that. So like your overall quiz grade gets better. Like everything is there to help you do, is there to reward your efforts. When you improve and you show it, you get rewarded for it. Like it's a very nice grading system, I think. Like you are guaranteed to get the grade you deserve or better. And for most of the people, the reason why they can't get the grade they deserve is because they already have the best grade, right? So if like you get an A, like I can't give you over an A, you know, it's just like, yeah. But from deserve or higher in many cases. So I just wanted to make sure that about grades because some people were concerned about that. Some people asked me about the solutions for test 1. I actually went through that in class, so you actually have it in your class notes. So no, I'm not going to post the solution for test 1. I posted solutions for test 2 because there was no meeting time between test 2 and now that we could have met. So I posted that. Is this thing working? Can you guys hear me?
Yeah.
Yeah.
Okay, my Zoom is telling me that something is off. Okay. Yeah. And like I was saying earlier, asking your groups members to help you out. If you have any questions on material at this point, I would say ask it in Piazza. It's finals week, so I'm getting a lot of emails from all over the place, and I don't want to miss one of your emails, as well as it's better for everybody because if you ask a question and I answer it on Piazza, everyone sees the answer, everyone gets to benefit. Sometimes students don't even know they should be asking certain questions, and they benefit from me answering it for everybody. So you can ask it there, and I will see it, and I will answer them. So at this point, like the only thing I would say you should email me about in terms of questions is anything that is of a very personal nature, where it's not with the material, the class material itself, it's with something else that you need to make me aware of. Yeah. So overall, I think it should be fine. I think your final grade should be at least what your average grade is over the semester, if not better, because you're getting more opportunity for partial credit, as well as if you do improve on the final, I will take that into account when assigning your grades again, because you know who you were 2 months ago when you were taking test 1. It's probably not the same kid you are now. You know, maybe test 1 was your wake-up call, and you really put in the work to get somewhere better now, and you are better now. So it's like, you know, if you were a D student 2 months ago, but now you're more of a B student, you know, I'd like to judge you more as a B student than a D student. B as in bat. Yeah. Any other questions?
For the, like when you're talking about how on the final, if we do better on something that previously we might not have done well on, should we, like, since you're not like purging our previous exam score, should we like email you and be like, hey, I did well on this, but I messed it up on a previous quiz? Is there like how should we go about like telling or finding out how we can get?
Well, you don't have to email me. So how it's going to work is I will update your final exam grade in your Jupyter grades, right? So there's going to come a point where all the grades you have, they're going to be in Jupyter, and you're going to see what I'm seeing, right? And that's going to happen before I post the grades officially. So when I finish grading the final, I'll send out a mass email and I'll tell you guys, hey, I graded everything. Your report cards are complete. Look through your report cards, and if there are any issues, because maybe I made a typo or something, you never know. So look through your report card. If there are any issues, let me know. And at that point, you can reach out to me. And I'll also let you guys know, so you guys will know what grade I'm intending to give you. And if you feel like, well, you know, I think Jhevon might have forgotten to consider this, then at that point you can reach out to me. But again, I would say don't do that frivolously, because I'm already giving you guys so much opportunity to do better than your numerical grade says you should do. So, you know, only if it's like pertinent, right? Like if you got like an F on test 1, and then, which I don't think anyone did. Like if you got like an F on test 1, so it's really really messing with your grade, and then you really did better on the final. Maybe you can point that out. But if it's like, you know, I think I got a B- on test 1, and you know, I think, you know, right now you should think of that as a B+. But like, no, that's not. I don't think that's worth it. You're already getting enough of a cushion where that's already working in your favor. It's not worth asking me about it. So that's what I would say. So you will have the opportunity to see all your grades, and you can have the opportunity to see the grade I intend to give you before I officially give you, and you'll be able to review. And if there's anything amiss, anything you're concerned about, anything that, you know, you think you need to reach out to me at that point. But don't like preemptively reach out to me. Like I'll be getting dozens of emails during finals week anyway, so it's not gonna be efficient until I'll let you guys know, here are your grades, here's what I intend to give you. At this point, if you have any concerns, email me now so I know to look at my emails for the next 24 hours and look out for specific emails like that. And yeah, so that's what I would say.
Okay, thank you.
Other questions, concerns?
Can we get like practice questions for the finals?
I believe there's a practice final, although it's a written final, which is good because I'm going to ask you to write out your work. I believe there's already a practice final on the class website. So I think just going through that would be good. It's probably been a while since you looked at test 1. So I think you probably forgot all those questions. So you can actually redo test 1 and see how you're doing, how your answers measure up to mine. But yeah, in terms of practice, at the end of the day, you guys have a lot of material to go over. But yeah, the final is essentially going to be like a combination of test 1 and test 2. So you can look at those and you can swap out the problems for different problems, maybe even ask a tutor, or this is what your group can come in handy with. So you can have every member of your group they can do it themselves or they can get help doing it. I think everyone asking a tutor might be better, but what you can do is look over test 1, look over test 2, and like swap it out with problems that are of similar difficulty and create your own test. And then what you do is you pass the tests around the group. So group member 1 and group member 2 can switch the tests that they wrote for each other. And then you guys do those as practice. And why I would recommend that is because you want to practice how you want to perform. Like you're not going to see the final before you see the final. So if you are the one who wrote the problems that you're going to practice, you have an unfair advantage that you wouldn't have. So you want the problems to be a surprise. So if you write the problems, you should give those problems to someone else so that they're like, whoa, where did these problems come from? And they have to figure it out on the spot. And same thing for you. So that's another way I would say you could use groups. So all the group members can look over test 1 and test 2. Just keep this exactly the same format, but just swap it out with different problems and then pass those tests around. And you can have 4 or 5 practice tests if you can even have the time to get through all those. So that's what I would recommend. But I believe there's already a mock final posted in written form on the class webpage. Any other questions? But yeah, I mean, overall, I feel it's gonna be fine. I don't envision anyone doing worse on the final than they've been doing. So you'll either do roughly the same on average, or you can have the chance to improve. So I don't think it would be a surprise to anybody or anything like that. Like, I'm not gonna ask you like a problem type, like I've never asked you before or anything like that. It's not gonna be that. Everything should be expected. You should see every problem type that I'm going to ask. You should have seen that problem type before. It's just the actual functions that are involved will be different. And just that the combination of the questions would be different, but there won't be any surprises, let me put it that way. So if you study well, you study smart, I don't envision the final being an issue. Any other questions, concerns, comments? Now they've started drilling. I don't know if you guys can hear that.
Construction.
Yeah, they're doing something on the facade of my building. Yeah, I've essentially said everything I wanted to say. So it's just a matter of if you guys have any more questions or concerns. But I do really want to stress, don't stress. Don't like stress yourself out. Like, I don't think there's anyone in the class failing. Like, everyone's passing. So I don't envision anyone failing. Worst case scenario is a D, and I don't think there are even many people in the class with a D, in fact. I don't remember off the top of my head, but I just...
Oh, I have one more question. Do we have to, because I remember on test 1 there was one problem where we had to use like the limit definition to find the derivative. Are we gonna have to do the
Yeah.
same on the final?
Yeah. Yeah.
Okay.
For sure.
Can you just go over one of those?
I would ask a question like that, like out of tradition. Like, it's one of those things where in a Calc 1 class, everyone asks you to do that. It's one of those things.
Can you just go over one of those, just because like I know there's like a few different like possibilities where you have to like multiply by like the conjugate, like if it's like a square root or something. So
Yeah.
I want to be sure.
So the thing is, once you know how to set that up, it's just your limit strategies from that point on. So by studying for limits, you're automatically studying for that as well. But let me throw some stuff at you. Find f prime by limit definition. So here's an example. What if I ask you to find the square root of x? What would the setup look like?
Square root of x plus h, and then minus square root of x over h.
No, not exactly.
A limit in front of it.
Yes, that's actually pretty important, believe it or not. Like, without the limit, it's not a derivative. Without the limit, it's actually average rate of change. The derivative is what we call instantaneous rate of change. So the limit is actually an important thing. Don't leave off the limit. as well as you need to keep writing the limit until you actually take it. Okay, so that would be the setup, right? So you need to remember what the limit definition says. So that says f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. Now, once you actually do that, it's now just a limit problem, right? So whatever limit strategies you would have, so we know that, okay, we first try to plug in h equals 0, but I can't do that because there's division by 0. So I need a way to simplify this so I can plug in 0, right? So what's a way that we can simplify this?
Multiply by square root of x plus h plus square root of x over square root of x plus h plus square root of x.
Right. Right, multiply and divide by the conjugate. So that's a strategy that you know, right? That's one of the strategies I told you about. And so that would get you to the point where this looks like x plus h minus x all over h times x plus h plus radical x. The x's die and the h's you'd be able to cancel. And so you end up with the limit as h approaches 0 of 1 over radical x plus h plus radical x. And of course, at this point, you can plug in h, so I can stop writing the limit sign. And so that's just 1 over 2 radical x. Right, so that was a strategy that you know. Oh, by the way, because some people might be thinking of this as very sneaky, but you are not allowed to use L'Hopital's here. So you'll notice that the definition of the derivative, it usually goes to a 0 over 0 limit. However, because L'Hopital's rule uses the derivative in the rule, and here you're like, we don't even know what the definition of the derivative is. We're using the definition to figure something out. You can't just use a shortcut derivative to do it, right? So to apply L'Hopital's rule, you'd have to actually differentiate the square root of x. But if that's the whole point of the problem, is to differentiate the square root of x. So it's kind of a circular to actually apply L'Hopital. So you can't do anything fancy like L'Hopital's rule. However, algebraically, you can move things around. So another example would be something like, what if I ask you to find the derivative of 1 over x? So then you would say f prime of x is the limit. I might ask you to actually write down the definition as a part of your answer. So let me do that. Because a lot of times students actually plug things in incorrectly. So I'll probably want to give you partial credit. So if you at least remember the definition, you can get a couple points, 1 or 2 points. Because some people actually, the f of x plus h confuses a lot of people. So here, remember f of x plus h, just go to the function and replace x with x plus h. So you have that. At this point, you want to simplify this because you can't plug in h. You can have another strategy, which is to multiply and divide by the LCD. So that's a simplification strategy that we spoke about. So this guy multiplies those two, and this guy multiplies that. And so here, the x plus h would cancel. The x's would cancel. And on the bottom, you would have this. You'd have x minus x and then minus h. So this actually simplifies to minus h over h x plus h. Notice that I'm writing the limit the whole time. The h's cancel here. So I have minus 1 over x times x plus h. And now I can plug in h equals 0 without making the denominator 0. Of course, unless x equals 0, but I usually won't care if you identify that or not. But yeah, also notice that I keep writing the limit until I actually get to a point where I can plug in h equals 0. So all of that, like if you don't write the limits, I will deduct points for that. So showing your work in this way is going to be important. Yeah. So, I mean, hopefully those two examples kind of tells you what you need to do. On a final, what can I, here's something that I've seen mess people up, but it really shouldn't. So maybe I'll do an example like that. You're allowed to separate limits. You can find a limit of a sum as the sum of the limits. So for example, if I gave you a sum of functions, sometimes like so let's say I gave you x squared plus 1 over x. So then you would say f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. And so now when you go and plug this in, you would get x plus h squared minus 1 over x plus h minus, open parentheses, x squared plus 1 over x, right? Now, a lot of students see this and then they try to simplify this whole thing all at once, and then they end up with problems because of the algebra. However, what you can realize is that this is just the same as doing the parts without the fractions plus doing the parts with the fractions. And that might make it a little easier. So each of these you'll know how to do relatively quickly. Here you're going to end up with 1 over x squared. Then you're going to add that answer to 2x. So if you see two different kinds of functions, you can actually separate them. You can use the fact that the derivative of a sum is the sum of the derivatives. And so you can actually split it into two derivative limits. Just do a limit for each part. And that might be easier conceptually for some person, for some people. Can split into dos derivative limits. So occasionally on a final, I'll put a problem like this. Not guaranteed to do that here, but if I do, that's how you can do it. Like this is like the worst case scenario. Like worst case scenario. Like if I want to be mean and I'm like off my rockers and I'm like, oh, I'm gonna try to get, I'm gonna show these people, you know, which isn't gonna happen. But worst case scenario for a problem like this is going to be something like this, where you have a sum of two different kinds of functions, but it's really not a big deal. You can actually just separate it and deal with each part separately. And at the end of the day, it's just now using your limit strategies. You know, I need to simplify so I can plug in h equals 0. So I know how to simplify complex fractions, multiply by the LCD over itself. I know how to simplify stuff that's a difference of radicals, multiply by the conjugate. I know how to, if it's just a polynomial, just expand the parentheses, cancel stuff, regroup terms, factor, cancel. So yeah, you have all these strategies that you can use. But yeah, that's pretty much worst case scenario, I would say. Any other questions? Okay, I think we're golden. So won't take up any more of your time today. But yeah, I just wanted to lay those concerns to rest, answer any questions or concerns that you have, tell you about the final. So the final is next Wednesday at 9:30 a.m. Grade scope, usual stuff. That's the format. I expect people to perform how they've been performing on average so far or better, which is, I think, good news because, like I said, the entire class is actually passing. I think out of the entire class, there may be 2 people or so with like a D, but a D is also passing anyway. So the majority of the class has a C or higher. So you shouldn't expect anything lower than that. So it's if you're happy with that, you can just do what you're doing. If you want to actually have a chance to bump things up a bit, you know, study smart for the remaining week, study with your groups, get some insights from other people. If someone in your group was getting better grades than you and they reveal that to you, you might ask them for some of their secrets, whatever. Do what you got to do. But other than that, yeah, I would say it was nice meeting you all, even though some of you guys don't like turning on your camera. I have no idea what some of you look like, but good luck to your finals. Good luck in your future endeavors. It's been fun. It's been real. Hope you guys enjoyed the class, learned a lot. Hopefully it wasn't too stressful for you being asynchronous, but it was structured so that you could actually learn in your own time, and then you had chances to ask me questions. Hopefully that worked out for you. Have any questions about the material? Post it on Piazza. Have any personal situation that you need to email me about, email me directly. But other than that, I would say it's all she wrote. So unless there are any lingering concerns, I think we're gonna go. But all the best to you all. Have a good rest of the 2020,
Thank
whatever,
you.
whatever,
Thank you, Professor.
whatever that means. Like, hopefully 2021 is much better for all you guys. Let's finish strong. Yeah, and we are going to end there.
Thank you.
Thank you.
Thank
All right.
you.
Thank you.
Take care. I'll see you guys in the next one.